Okay, so let's discuss a drawing process where the initial diameter of the blank is 100 mm, and now you need to draw it such that the diameter, I mean when you stretch it, let's say the diameter is reduced, and so the initial dia of the blank is di, which is 100 mm, which is larger. Now when you draw it by applying a force, and there you'll have a die and you'll apply a force, so it will take the shape of a die. So the final dia is less, and that is 50 mm. Now the load that is required to do this process is related to the initial remember that the area of cross section is not constant throughout, so this is, again, you have to take a in between, like you have to just take a small element, and then you have to just let's say the element is d, and then the stress is sigma, so apply the load, find out the load, and then you have to integrate. So but the final expression that comes out is AF is the final area of cross section into sigma naught is the yield stress or the flow stress, into ln the ratio of the initial and the final area. This is the load requirement for performing a diametral change in the drawing process. So AF is the final cross section, that is pi by 4 50 whole square. Sigma naught is the yield strength or the flow stress at which the metal starts flowing, 50. ln A naught by AF will be pi by 4 d square by, so d naught square by df square. So this is pi by 4 into 150 whole square into 250, 150 whole square into 250 into ln t naught is like it should be initial by final. Remember, initial by final, I think the way we have represented in the figure is this should be d naught and this should be df. Okay, initial is naught and final. So initial by final, that is 100 by 50, 100 by 50 whole square, so it will be 2 ln whole, ln 2 and ln 4, and then it will become ln 2. So this, if you calculate, you get close to 680.37 kilonewton. Okay, that should be your load for performing this, 680.37 kilonewton. So roughly 680 kilonewton you can say load required for drawing. So this is a direct formula for drawing. Okay, thank you.